Hi, welcome back. This is Professor Ridge, and today's lesson on section 7.3, multiplying rational expressions. Well, it's not. It's radical expressions. Excuse me. All right. So the first rule, the product rule, which I'm sure you've seen before, but we'll just cover it again. Product rule. Okay, so the product rule basically says that if you have the same index, the nth root of a times the nth root of b, then you can make it one radical with the same index, so that's the key, and then you just multiply the numbers inside, the two radicands. So a, nth root of a times the nth root of b is the nth root of a times b. Alright, so let's try a couple of these. Multiply. So number 8, we got square root of 6 times square root of 5. Since they're both square roots, we can just multiply the numbers inside. Make it square root of 6 times 5, which is square root of 30. The fourth root of 10 times the fourth root of 4. Well, I wrote that backwards, but it doesn't matter. Okay, they're both fourth roots, so the fourth root stays the same, and then we multiply the numbers inside, and we get the fourth root of 40. Number 16, if I have the fifth root of 9t squared times the fifth root of 2t, again, they're both fifth roots, so we can just multiply the numbers inside. And 9 times 2 is 18. T squared times t is t cubed. So you get the fifth root of 18t cubed. Okay, and it doesn't matter what the radicand looks like if they're both sixth roots, so we got the sixth root of a over b minus 2 times the sixth root of 3 over b plus 2, so they're both sixth roots. So we leave that. And then we're going to multiply the two fractions together, the two radicands. So it's going to be the sixth root of 3a over b squared minus 4, because that's the difference of squares. And there you go. Alright, so now I want to review simplifying by factoring. So if I want to take the square root of 12, for instance, what I'm going to do is I'm going to factor 12 using tree method or whatever method I want. So 12 is 4 times 3, and 4 is 2 times 2 times 3. Now, whatever the index is, since the index is 2, I need two of a kind. I need a pair, 2 inside equals 1, 2 factors inside, 2 2's equals 1 2 outside. So that's the way I think of it. So the 2 2's inside become 1 2 outside, and the 3 doesn't have a pair, so it stays inside. So that's equal to 2 root 3. Okay? If it's cube root, you need 3 of a kind. So if I did cube root of, say, x times x times x times x times x, we're looking for 3 x's inside, make 1 x outside. So whatever the index is, and then you got x squared left inside. If I did fourth root, x, 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 I need 4 inside, would make 1 outside, and then we still have the 1 left over. If I had fifth root of x to the fifth, so that's 5 x's. So now the index is 5, so I need 5 x's inside, that makes 1 x outside. And then there's nothing left inside, so it's just x. So see how that works? So the index tells you what, how many like factors you need inside to make it one of those factors outside, if that makes sense. Okay, because remember from the definition we're saying, for a cube root, we're saying what to the third power is that number. So if you have 3 x's, that's x cubed. Cube root of x cubed is just x. Fourth root of x to the fourth is just the x. And then fifth root of x fifth is just x. Okay, so we're looking for whatever the index is, we're looking for that many of a kind. So if we did square root of 300, we do 300, 3 times 100, 10 times 10, 2 times 5, 2 times 5. Now, realistically, once I see I have the pair of 10s, I'd pull a 10 out. But I just want to show you the whole technique. You know, if you factored it all the way down, you got 2 2s, 1 3, 2 5s. It's square root, so we're looking for a pair, 2 of a kind. 2 2s inside, make 1 2 outside. 2 5s inside, make it 1 5 outside. And then you got the square root of 3 left over inside. So we get 10 square root of 3 is our final simplified answer. Alright, if I wanted to simplify x to the square root of x to the 5th, y to the 6th, z cubed. Now, realistically, I don't want to write x times x times x, 5 x's. You know, that gets pretty tedious after a while. 6 y's, 1, 2, 3, 4, 5, 6, 3 z's. And again, if we think of it, it's square root, so I'm looking for pairs, 2 of a kind. So 2 x's inside, make 1 outside. There's another x, pair of y's, 3 pairs of y's. So I'm going to get x, x, y, 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 z. Oops. And what's left inside? Just 1x and 1z. So we got x squared, y cubed, z, square root of xz. Now, that's fine, but what if I wanted to do square root of x to the 75 and y to the 63 and z 12. I'm not going to want to write x times x times x 75 times. So the idea is I can either connect this back to the last section where I can think of this as to the 1/2 power, and I'm going to divide, or I can look at here, saying, let's look at A again. X to the 5th is 5 x's. And so I want to know how many groups of 2, how many 2 of a kinds are there. So that's the same thing as saying what's 5 divided by 2? That's 2, remainder 1. So the 2 is the 2 that come out, and the 1 is the remainder that stays inside. And then if I do y, 6 divided by 2 is 3, remainder 0. So you got y to the 3rd, and there's no y's left inside. And then 3 divided by 2 is 1, remainder 1. So you have the 1 that came out, and the 1 that's left inside. Okay? So if we do that technique, 75 divided by 2, that's going to give me 35, 37, remainder 1. If I did 63 divided by 2, that's going to give me 31, remainder 1. And 12 divided by 2 is 6, remainder 0. So now, I know that x, a y, a z come out. I'm doing square root, so 75 divided by 2 is the 37, remainder 1 for x's. For y, 63 divided by 2 is 31, remainder 1. And z 12 divided by 2 is 6, remainder 0. So that's my answer. X to the 37, y to the 31, z to the 6, square root of xy. So we can extend this to any root we want. X to the 23rd, y to the 15th, z to the 38. Let's do 39. So we do 23 divided by the index, which is 5. So that's 4, remainder 3. 15 divided by 5 is 3, remainder 0. 39 divided by 5 is 7, remainder 4. So remember, the quotient, that's the number of 5 of kinds you have. So that's what come out, and then the remainder is what stays inside. So I'm going to have x, y, z, fifth root. Okay, so let's go through this again. 23 divided by 5 is 4, remainder 3. 15 divided by 5 is 3, remainder 0. 39 divided by 5 is 7, remainder 4. And that's the answer. Okay, so that's how I deal with powers of variables. I just divide by the index. Okay, so let's look at 56. 8, 10. Let's see, I know 10 goes into it. 81. 81's 9 and 9. 10's 2 and 5. So I have fourth root of 2 times 4 3's times 5. And then I'm not going to do x to the 9th. I'm going to do the shortcut with the dividing. So 9 divided by 4 is 2, remainder 1. Okay. So with the numbers, though, I factor it usually. So 1, 3 comes out. We know we're going to get x. Fourth root, we know we have the 2, the 5 left over. So 9 divided by 4 was 2, remainder 1. So our final answer is going to be 3x squared, fourth root of 10x. There you go. So simple as that. Now, when I simplify using, putting both of these things together, when it says simplify, multiply and simplify, or just simplify, didn't matter which it said. If I have square root of 10 times square root of 35, I'm not going to actually multiply these out, because the idea is I'm going to factor them. So square root of 10 is 2 times 5. So see, I'm not going to go 3 times 35 times 10 is 350, right? Because I'm going to factor it anyway. So it's just kind of wasting my time to multiply it together. So I'm going to start factoring. So I got 2 times 5 times 5 times 7. It's square root, so I'm looking for 2 of a kind, pairs. So 5 comes out, 14 stays inside. So it's 5 square root of 14. Let's try another one. How about number 68? We got square root of 5 a to the 7th times square root of 15a cubed. Now with the exponents of variables, I use exponent rules. So 5 times 15 is 75, but I don't really care about that because I'm going to factor them. A to the 7th times a to the 3rd, I'm going to go ahead and use exponent rules and make that a to the 10th. And then with the numbers, I'm going to factor them out. 5 times 15 is 5 times 3. So I know 5 is going to come out, and I'm going to go 10 divided by 2 is 5, remainder 0. So I'm going to get a 5 comes out, a to the 5th, remainder 0, and then all I got left inside is square root of 3. So that's my simplified answer. Okay. All right, so that concludes the lesson for 7.3. Go to My Math Lab and complete your exercise there, and I'll see you next time.